Welcome to day 2 of lesson 7.5, and we are going to specifically focus on the parametric equations that allow us to track and to determine the projectile, motion of a projectile of many different forms. But basically you have these two equations. You have your two parametric equations. One is x, and yes, these need to be memorized. And one is for your y, and it has many different components, so let's talk about that. I've listed them here for you. The t is the parameter of time, usually in seconds, just like we've been doing. Theta will be your angle, and it usually is given. H sub 0 is going to be where it starts. For example, if you're shooting a basketball, you're going to not start from the ground. You're going to start at a certain height. If you are playing golf, you are going to start on a tee, which would be on the ground. If you're kicking a ball, it's from the ground. I mean, different things are launched from different levels. V sub O is going to be your velocity. The velocity is usually given to you as well, and it is usually in feet per second or meters per second. Sometimes it's in miles per hour, and you have to convert it to feet per second or meters per second. And the reason is because your gravitational constant is going to be you're either going to use feet per second squared or you're going to use meters per second squared. And depending upon what your velocity is, that will determine which constant you use, and you may have to do some dimensional analysis to convert those as well to feet and to meters. Also, I want you to note that you're usually going to set your angle mode in degree mode because you have a theta. So you're normally going to be in degree, and you will alter the window as you need to depending upon the size of your graph and your function. The range is the horizontal distance traveled by the object. And if you're traveling horizontally, you're using the x parametric equation. If you want to know how far something's descended or what the height is, you would use the y. How far it's traveled until it's on the ground or landed, you would use the x-intercept. So to get the x-intercept of your function, very often you need the 0 or you need the rectangular equation so that you have to eliminate the parameter that we learned in the last lesson. Okay? So to get a visual, if you have something that's been launched here, and you would call that would be your theta. This value right here, that would be how high it was, the y. So I'm going to turn my paper and I'm going to write that equation. This would be the t velocity sine theta minus the gravitational constant. Okay, that would be your y. Your x would then be the horizontal distance. So that would just be the time times the velocity and the cosine of theta. It'd be easy to remember. Cosine is your x, sine is your y. But this will help you when you are interpreting and dealing with different applications. We're going to do one together in this video. This first example has John attempting a 43-yard field goal. He kicks the ball at a 41-degree angle with an initial speed of 70 feet per second. The goal post is 15 feet high. Will the kick be long enough to make the field goal? So let's identify some of the parts of the problem that we already know. We know that theta is 41 degrees. We know that the velocity is 70 feet per second, which is nice. It's already in feet per second. I don't have to do any conversions. You need to check that initially. How high is it initially from when it's first being kicked? Well, he's not punting it. He's kicking the field goal, so it's at the ground. Okay. So the first step that I would do, and you know, there are a couple different ways to approach it, but the first thing I would do would be to find the ball, the height of the ball. I would find the height of the ball after it's traveled the 43 yards to the goal. So I want to know how high it is in 43 yards, and then I'll determine is it high enough to clear the goal post. So how high after it's traveled 43 yards? That would be the first thing I would do. Well, I need to know if it's traveling 43 yards, that's using my horizontal. So I'm going to use X first. And I'm going to, if I know that I'm traveling 43 yards, all of my problems are in feet. So I first need to change my yards. 43 yards would be how many feet? Multiply that by 3, that's 129 feet. I would need to do that conversion first. Okay? Then I would say if my horizontal distance is my X, I would want to know when it traveled 129 feet, what was the time that it took to travel that distance. So t times my velocity of 70 and cosine of 41. Now, you put this in the calculator. You need to make sure you're degree mode, obviously. And I'm going to take 129, and I'm going to divide it by, so 129 divided by 70 times cosine of 41. And that gives me t, which is 2.442 seconds. So that's how long it takes to get 43 yards for the ball. Well, then I'm going to use, that's how long it takes to get to 43 yards. Now I'm going to use y to get the height. Use y to get the height in let me do that. I meant to say 2 and I wrote 4. I hate it when that happens. 2.442 seconds. So I'm simply going to plug that in for t, right, into my y equation because I'm getting a height. So I have y equals, and I'm going right back up here to my formula. I'm just plugging things into the formula. My t, which is, let's speed this up a little bit. There we go. I'll stop moving it. Okay. I'm going to use 2.442 times my velocity, which is 70. I now have sine of 41 degrees minus the gravitational constant, so I'm going to use 1/2 of 32 because I'm in feet per second. And then I'm going to multiply that by the time squared, which is our 2.442 squared. And I'm just going to write this on there so that you know that I didn't forget it. We're not adding anything, right, because our h is 0. We're starting from the ground. Now, this is simply plugging this in the calculator, but you have to be very careful that you get parentheses and that you plug everything in. Again, you're in degree mode, and that you type things in the right order and use proper parentheses. You get that y equals 16.733 feet. Well, then you determine, is that high enough to clear the goalpost that's 15 feet high? Yes, it is. So this was the second thing I did. Well, the first thing was to find the height. We did that. Then the second was the ball high enough to clear the 15-foot goal? And the question, or the answer is, of course, yes. All right, scored because 16.73 is greater than 15 feet. Okay, so a lot of times you'll see that your worksheet has all different kinds of sports, many different applications for this, but you need to determine, am I trying to find a horizontal distance? Am I trying to find a height? Sometimes you need to find the time like we did here and then apply it to the height. You can also use your calculator a lot of the time and put the equations in the calculator, find when the intersection is of the two lines. You can find, if you want to know a peak, vertex, you can, many different applications and ways to attack these problems. I don't want you to think you always have to do it one particular way. So this assignment has only 9 problems, but they have many different components and lots of different sports applications and a couple that aren't sports. But it's kind of fun to do these because you see the direct application for the parametric equations. I'll see you in class. Thanks. I'm back real quick. I want you to look at if you've got some extra time real quickly, I'd like you to look at page 472 in your text. Very good application of how to use this in the calculator. So if you would please do that, it will kind of give you a heads up and some different ways to approach the problems. Now I'm really leaving. Thank you. I'll see you in class. Bye.